Live. Let's do the usual first thing first and get some music going. Been enjoying listening to some of these like Zelda playlists recently. What's up, Alex? Oh yeah, that's good. That's nice. Thanks for stopping by the stream again, you legend. Extra special. Thank you, in fact, for showing interest in the game dev streams. I don't care if Nintendo claims, because this channel's not monetized on YouTube, so as long as they don't take the stream down. All right, let me just I'm a little bit frazzled at the minute, going from one stream to another. Quite a bit of juggling. Let me just make sure both streams are up and looking good. I don't know what that noise was. So normally I have a whole different stream overlay and everything, but I don't have a camera. And I've also been working slightly different recently, so I decided just to go full screen to be able to see more of what I'm actually doing, which if you can't see me, I feel like is the next most important thing anyway, right? So the Twitch stream's looking fine. Gotta make sure we're actually in the right category and everything, and the title's right. Game dev, making my own engine in C, software and game development. Nice. Not seen the stream on YouTube yet. Let's see. Could you please again share the link to YouTube for me to like over there? Sure. I think I might have set up a command if you do exclamation YouTube. I can definitely get you the link, but I started adding commands. Yeah, there we go. Exclamation YouTube. And then, yeah, there's the stream on YouTube. Live game dev, making my own engine in C. So I do need to manually share this in the Discord. Okay. Oh, I just shared a link to the wrong Twitch channel. Alright, I think the post in the Discord is done now. I think we can actually get started. How's everybody doing? All I've done since Click Stop Streaming is rush about to set up this stream, quickly log into my YouTube dashboard to rename the VOD so the VOD watchers aren't confused about the title, still saying it's live on my main YouTube channel. And then I ran downstairs and grabbed some bacon out of the fridge and some wasabi chips and some water and stuff, because we do need to fuel. Oh, I think I can take some more drugs now as well for my head. I think I could tell it's just fading off, like wearing off before. So, first things first. Oh, this screen isn't working. Oh, wait. Hang on. There we go. You were actually just seeing a still image. I hadn't done anything anyway, except for open the terminal. So I didn't miss much. Well, pretty funny. Want to see something dumb that for whatever reason Raycast does? We can celebrate anything with some confetti. I don't know why this app has that feature. Because it's actually an extremely good app. But pretty dumb. It might be funny for the stream though. In fact, I bet I can assign it a shortcut or something. Shall we actually do it? Oh yeah, we can spam it. Look at that. Definitely not going to needlessly tank any GPU with this. That is so dumb. I'm just having a few snacks. But if anyone has any questions, feel free. Give people a few moments to show up maybe as well. So we were talking quite a lot before about game dev for people. Just now started eating popped brown rice chips that wasabi flavor. Okay, I'm getting there. I never put drinks on my desk, but my setup, I've got so much stuff going on right here. I do mostly use the keyboard. I think I can get away with it. Gaming with drinks on the desk is really like you're just asking for trouble with flipping that mouse around. So I did actually recently change something about my setup this morning. I was using a tiling window manager called Aerospace for Mac, which is really good. But if you're running any kind of like anything that's just like not super lightweight, Aerospace, for whatever reason, just runs like shit. And every other tiled window manager on the Mac is basically like not good. Or there's just a lack of them. So I've just gone back just to using Raycast shortcuts. Because I don't need that much tiling anyway. My god, 5 o'clock shadow is real. I didn't shave this morning and it was fine this morning, but today, right now, it's not fine. I need to shave. Okay. Not that I shave, I just mean to shave my neck. I can't be clean shaven, that's gross. Okay. Just down some water. I'm sorry to do this, but switching from one stream to another. I'm still refueling myself. Need to eat, need to drink on stream. Okay. Terminal. Window. Earth and Heart. Tmux. Another Tmux pane. I tend to not want to use the entire window because I find that I only ever look at the center of the screen. So anything on the edges are just like peripheral. I like my main code down looking that to be kind of centered. You know what I mean? So not 100% sure where we're starting yet. I do want to do a little bit of an intro. Let's bring up our GitHub project. Yeah, so this is essentially all of the to-dos that I have right now. We have this section of the project that's just like my current focus. So I can look at a small amount of things at the time. And then this pane here is just new things I've added to the to-do list that are uncategorized. You can read through some of these because you guys might get a kick out of some of it. Strawberry milkshake, cows that give milkshake when milked. It's just like a random idea. But I swear I have a design document about that, which is why that's unsorted. Implement starter island so the village doesn't just be on its own. Yeah, a lot of this stuff is up in the air right now because we're making our own engine. Create a design note for random encounters. If it's more fun to have no map, it's better to do. Yeah, that's about Fog of War, which we implemented on the last stream. Make POI inspired by town in Japan. Hero for a coward. This is a video that I saw on YouTube of this place. It was a village that had lots of canals filled with koi fish. I don't know if that'll make it in or not. Maybe zoom out even more. Add boots as potential tool for improving walking ability in swamps and bogs. I really like that idea. That's definitely like golden. A lot of this stuff is like we're a million miles away from this, but it's just like when if I have a thought, I add it to the list. Boats, blah blah blah. Add reference to Sasprin and Adraville and Aquacure from Resident Evil 3. But anyway, this is the main thing. So booking us in from engine. We need to look at our engine. Trying to think of where to start a sort of opening discussion about what we're working on. I guess okay, let's start like this. I'm making my own engine. What that means, why, how it got to this place, well, I'll attempt to explain during the stream, but this definitely needs to be a video. But in order to explain why, there is something, a fundamental demonstration I can do that is a gross oversimplification, and really the real reason why is much, much more complicated. But nonetheless, it will explain in a nutshell, that is reality, the shell of a multi-layered onion. It's much more complicated. It will explain in a nutshell, right? And it's a gross oversimplification for anyone that wants to take it too literally and explain away why this is dumb. But I can do a demonstration, right? So, part of the process of making a game is obviously design. I personally choose to separate design and development to a certain extent. Although really they're the same. Development is, you know, the all-encompassing word for everything. But just in my head, it's sometimes useful. And most of the work that's been done on the game so far is design. And when it comes to design, the game is mostly designed. I feel like I have designed most of the mechanics of the game. There's still lots of fundamental things that aren't designed, because many things are best done when you have something tangible to play, right? And we don't yet, right? When it comes to the actual development, the actual physical making, the programming, the thing to show you, to feed that you can play, we're really early on. You know, we're months in, we're still not a year into that. And so it's so early that I can start from scratch. And in fact, doing what I'm doing doesn't have to be starting from scratch. Because the reality is, a lot of where we're at so far is just like figuring certain fundamentals out, creating development pipelines, etc. Because of a lot of it's already been figured out, it's not that different to change our engine or get rid of the engine or whatever, right? So, what I do have is what you guys have seen several times before if you've been paying attention to the Earth and Heart streams, which is we have a game maker project that does lots of different things, but you know, primarily it's pulling in data from a program that we made to generate level data and turning it into an actual game. Basically, it's converting it into tile data to draw the tiles on the screen, right? So, what's this demonstration? What I have here in the right-hand pane in my terminal here in WesTerm is a proof of concept as to test whether I'm really capable of making an engine that allows me to make my game, or just you can skip the engine part and just say just make my game. Really, same difference. We can talk about that later. But basically, in this right pane here, this is just a directory for a proof of concept, just to prove that I can do the fundamentals of my project, the most challenging things, the most important things, in C, which is just a programming language, right? It's a low-level programming language. And yeah, the way I figured they got to this point to do this proof of concept, which is, again, which is here. In fact, if you want to, you know, we can jump into some of the code or whatever if you really want to. Not like it matters really, but this is kind of it, right? Let's see. It's not crazy in length. 468. It's actually bigger than I thought, but not a lot, really. 468 lines of code, right? How I made this proof of concept, how I arrived here was I just did a bunch of basic tutorials and figured some things out on my own, just trial and error with C, making a C program, learning how to compile, stuff like that, right? Then I did a few tutorials, a few guides, written and in video form, was following along. And then I used AI to help me figure things out, to sort of like ask it to see if it can just implement some of these features that I want in my engine. And I get it to explain itself and get it to teach me how to do it. And then I can just do it myself without using AI, right? And the reason I did that is because I just wanted a quick proof of concept that I can make my game in C without an engine by implementing the fundamentals. So, this is where we got up to before, right? The game does a little more than this, right? But the fundamentals of the game, of what we've built so far, right? This is just a test room, but when I press space, it launches into the actual world. And what's happening here is that this level is being generated, this world is being generated based on data that is previously generated by a Rust program that hypothetically launches when the game launches, right? This actually happens to not be running the Rust program, but that doesn't matter because the Rust program is a separate entity. And what it does is all the Rust program spits out text and saves it in literally a .txt, which is just filled with characters that represent each of these tiles. And so what we made in GameMaker essentially just pulls that in, converts it into this gigantic world, turns it into an actual game, basically. You know what I mean? Right? So there's a few other things going on, but we've done more work than just that, but it doesn't matter at this point. So just, again, to convey, if we're going to run this game, this is just as a basic example. We're here in the GameMaker IDE. I press F5 to run the game. What's that, about 5-6 seconds to compile a game and run it, right? Then we want to load into the world. Now, bear in mind the fact that this transition screen exists that we're on right now. You know, that's by choice. but just go with me. So now press space to load the world. 1, 2, 3, 4, 5. So about 4 or 5 seconds. I'll load it into this, right? Okay. This is a proof of concept. That's it, done. Now, there's obviously some fundamental differences. A few things aren't built out to the same level. I'm using a different camera method. I've actually got a character moving on this screen, although this is hypothetically more complicated than what we've done it in there, because we've actually got a character running around here. It's actually hypothetically harder. And, you know, all the point of interest of the same tile. The reason for that is this was happening in a different piece of code after the fact in the previous one. But basically, the fundamental thing... Oh, the other thing I should say is what we just did there. Again, I'll run it one more time. This is running... This program runs the Rust program, actually. So you'll see it is different every time. Right? Whereas the other example won't even run in a Rust program. Now, that doesn't slow a program down, so it's a separate program. But you guys can already see where I'm going with this, I assume. There's a big difference between this. Let's count. 1, 2, 3. Okay, so 3 seconds or something, right? One, 2, 3, 4, 5, 6. We won't count this time because it's voluntary. 7, 8, 9, 10. So basically it takes twice as long. Oh, I forgot we implemented this, but it's kind of the same. So, why am I making my own engine? Well, like I said, if we're oversimplifying it grossly, and it is not a fair test for lots of reasons, but it's still true and practical and part of the reason, which is that it's way faster to just write something that runs C is C code. C as a programming language is, you know, almost as... if you want to remain human readable and workable, it's almost as low level as you can get. Like C code is like directly translates to machine code. So you're just directly allocating things to memory and stuff, right? But a big reason why, just forget all of the obvious things about it not being a completely fair test. There's other things going on in that project. Not much, but there is. Obviously, when you make a game in an engine, essentially, engines are filled with bloat. Unless you really are making a game that's going to use every single feature. But when you're making some like very basic 2D game, it couldn't be more bloat, really. So when you're compiling and running the game, there's so much that has to go on there. And that does translate to the performance of the game itself. So That's one thing. But honestly, it's just the simplest to demonstrate. The simplest reason to demonstrate. The real reason is far more complicated and something that is going to take a real well-researched video to explain. And there's several factors to it, and we explained a lot of it during the Valheim stream. But there's a several-pronged approach. In fact, maybe we can maybe we can do something here. Maybe we can draw some sort of explanation. Some kind, I don't know. And we will get on with some work. I'm probably going to do like a massive TED talk and then do a little tiny bit of programming and call it quits. But I mean, that's kind of what I'm expecting from these game dev streams. In reality, the serious work has to happen off stream. It's just this how it is. So we should have fun and do stuff like this for these streams. That's pretty bright. I'm not really a big GIMP user myself. Other than some Photoshop in for thumbnails on YouTube. But oh, I really zoomed. The zoom is out of control here. Okay. So, why with the engine, right? There's a several-pronged approach, right? Several reasons. One reason is sort of related to what we're just talking about. The sort of performance related, right? There's definitely lots of technical advantages to just the code is just got to be faster at just being C. There's lots of it's not just something magical about C code. It's just the fact that, you know, it is low level, so it will be faster, but also, you know, trimming the fat by just making the engine just do what you want it to do is just going to be obviously more performant, right? I think like that's clear to anybody, right? Then there is another major thing, which is just that I want to just get better and level up as a developer. You know, I've been making games for a long time, and for years now, I've kind of like felt stagnant. And I love sort of learning things and getting better at things. So I want to learn different languages and challenge myself technically. And doing something like making your own engine in like a programming language that's basically been the same for the last 30 years is something that most people would describe as difficult, I think, just subjectively. I'm not necessarily saying I actually agree with that after my current experience, but we'll get into that later. So performance is one reason. To improve is another reason. What I would also say about performance as well is that it could also be best for the game, right? Like, if you're thinking about your role as a game developer to make the best game possible, maybe you making your own engine may not be the best way for you to make a game. Maybe it might be a waste of time. But if hypothetically you could do that with no technical problems, if the game does end up being more performant, does that mean that you're making the best game possible? Maybe. I mean, if it's just the same game, it's an apples to apples comparison if you use an engine or you make your own. But one's more performant and one's less performant. Well, this is the best game out of the two, right? Hypothetically. So, out of making the best game / more performant game and me improving, there's two more things. And I'm going to do the most complicated one last. The other prong to this approach, or why, is really to do with workflow. This is going to be like very subjective. But for the way that I've been working recently, it's essentially all revolved around the terminal, right? Like, even when if I just open another tab real quick, like, even when I was making a Game Maker game, I'm still basically working like this, right? Like, my game right here, even though these are all Game Maker scripts, you know, we're still working here. I don't have a GML plugin installed in this Vim setup, but so there's no code highlighting. But I was still working in a terminal like this, right? Even when I was working with the engine. And so every time I wanted to do something, I was having to open up the Game Maker IDE to add an object, to add a sprite, whatever, right? Working in C code means I'm just here in my editor, I'm just here in my terminal, I'm doing everything with the keyboard. I'm oversimplifying, but this just means that my workflow can also be faster, which might mean, again, hypothetically, as long as there's no technical roadblocks that prevent me from doing anything specific, it might mean that overall I'll be faster, not just on individual tasks. But even if it's just individual tasks, there's validity to that. Like, if I'm only faster whilst I'm programming, well, you're going to spend most of your time programming, so that's still good, right? So this is the most scuffed diagram in the world because I've never done anything like this before. But this is where we're at right now, right? We're doing it because it's more performant. It might make a better game. You get to improve as a developer. Could have a better workflow, which might make us faster. What's up, a wild weeaboo? How goes engine development? Really good so far, but I'm like mere days into it. So we'll see. Very early. I just thought of this was the first stream I've done since deciding to do this, because I was working in Game Maker before. So I just thought talking about why a little bit. So these are the 3 prongs so far of why, right? It'll be more performant. That hypothetically, if we make the same game twice, but one's more performant, one isn't, right? That means it might be the best game. I get to level up and improve as a developer. From a current workflow, you know, just avoiding any ID or anything like that, other than what I'm currently working in, does definitely improve my workflow, makes me faster. The last reason is the most controversial, though, and the hardest to talk about, because I'm really not the guy for this talk. And that is the basically the enshittification of tech in general. Does this look like a steaming pile of shit or no? Probably not. So yeah, we have to really start talking about this. I'm not writing in shitification. If my camera wasn't broken, I wouldn't even be drawing a diagram. I'd feel more comfortable just talking to you. But because you can't see me, I feel like I need to do something visual. So this is a catch-all term. Add the ability to do sane input handling to that list. Yeah, I mean, if we're really gonna get into the real nitty gritty, the reasons become copious, and probably even far more than I would even be able to come up with as somebody that has never done this before, and is brand new to see. But yeah, if we're gonna get very specific, there's lots of crazy things we can get into, which that could be fun. But anyway, actually, this is the enshittification of everything is sort of related to what Weeaboo is saying. I'm trying to think where to start with this topic, because it needs to be a video in itself. There is a general sentiment out there in the ether amongst certain developers, game developers, programmers, software engineers in general. It's not necessarily the most common sentiment or super popular. And I do think to some people it perhaps verges on some alienation and pretentiousness and self-righteousness. I like to be quite self-aware, so I think it's fair to say that going in. But what I'm about to describe, which I will get on to describing it, I'm going around the houses a lot, I know, but I'm just trying to be clear. The sort of sentiment of things that I'm about to address. Oh, I've just realized I've had a window covering my YouTube chat. What's up, YouTube chat? Thanks for stopping by, Zanti. I'm back, and now we can talk about game dev without killing Valheim machine. True. Welcome to my TED Talk. All right, let's have it. Hell yeah. Performance check. Level game dev check. Workflow check. I'm more of an artistic type. The window looks like torture to me. It's so horrible. I've never even opened this up before to draw like this, but I thought you'll get better. Yeah. Nice. Caught up on the chat now. So the sentiment I'm about to describe, to summarize this final point of the enshittification of everything. Oh, the programming window. Oh, got you. I see what you mean now. I was behind on the chat, obviously. My bad. So what we're about to describe, I don't really want to force this on anybody as being the correct way to think, because that's bullshit. Like, you have to work the way that feels right for you. And what's right for you is relative to your place in your life, your career, your experience, and also just like personal tastes, right? Your education. But what I'm about to explain is something that in my personal opinion, when trying to look things up and research things and watch loads of videos and listen to lots of podcasts and read what lots of people are writing about the way of things in the world, especially in tech. In my opinion, this is expressed by some of the most talented people that we have, and most sort of proven, let's say. People like John Carmack, famously heralded as, the greatest programmer of all time, whether it's true or not. Jonathan Blow, Casey Muratori, any of these people that you're going to see as sort of like talking heads in the programming world that are like well-known programmers that, do actually get on camera and talk about this stuff. Even people like that, like the Primogen, who's not like he's doing like getting into game dev stuff now, but he's just, he worked at Netflix or whatever. He worked in tech for years. I think he kind of seems to feel this way. And I'm summarizing it in a way that not all of these people would describe it in this way. So forgive me for, summarizing it in a particularly sort of crass way, but I think it's sort of funny and does simplify it. But there's this sort of general belief that there is something happening that we can call the enshittification. of everything, basically, right? And the idea that so what that is and how that happens is really complicated. And it's a concept that I'm perhaps not qualified to explain, but I'm going to try, right? So, like, the idea is that whether we're talking about night, Alex, thanks for stopping by. See you next time. Appreciate you stopping by. Whether we're talking about it becoming commonplace for big tech companies to spawn out of nowhere, where their product is built on layers and layers and layers of other people's code, essentially, whether it's open source or otherwise. And what their whole product is essentially a wrapper for a bunch of work a bunch of other people did. Where you can end up in a situation where the people whose job it is to write the code have no idea what's going on below the hood, and that we can be in a place where no one at that company can know. Or whether we're talking about a situation that John Carmack specifically talked about at length, where after he left Meta, where he felt like it was a bad idea for lots of things in the code base to do with the VR headset he was working on, the Meta Quest and stuff, to be written in JavaScript. He felt like it was like fundamentally not the right tool for the job, that it should be done in a lower level language. And he was frustrated with the response that he essentially got from Zuckerberg and people at Facebook or whatever, was that, well, you know, the JavaScript programmers are essentially what we have. You know, we need to be able to do this at scale. The area, you know, where we're hiring people from, is full of JavaScript programmers. So just practically, you know, as a company figuring out how to operate, we have to hire those people, because if we were to do it in C or whatever else, you know, whatever, some low-level language or lower-level language, it could hypothetically be far more difficult to find those people, and it would be, you know, too expensive to train them. So you end up in this situation where something is made unoptimally or, you know, not in the most performant manner, just out of practicality. And so those first two things, the pitfalls are obvious, right? Because you can create this situation where things, you know, run less good, to summarize it, or work less good, and unnecessarily, in a way that people who are making them maybe even don't understand. And then you can stretch that out even further to go, well, if that's how everybody works, no one in the industry is incentivized to really learn how things work. And eventually, you know, we could be like we could have a sort of be like in a lost civilization situation where we have a bunch of people that we don't even know really how the things work that are around us anymore. The knowledge becomes lost to time. And then you can get to a much more nitty-gritty situation about people actually writing code. Now, I never went to school for anything to do with programming or computer science or anything like that. I'm completely self-taught, but I have been making games for a decade. And, you know, I did that at a senior position for some time at a company. And before and after that, I was doing it on my own, right? And nonetheless, as someone that's trying to learn and improve, you want to improve how to code. So let's actually take some arrows off this and say, we can say less performant, right? And we can also say lost knowledge. Right? But then we can also talk about actual code. Because Casey Motori has an incredible video on this subject about clean code. Clean code is something that you'll hear repeated ad nauseum in the world of programming if you just give it a tiniest Google. It's something that, to my understanding, that is still sort of taught in schools and in universities to aspiring developers, you know, the next generation of people that's going to make, you know, take the enshittification to the next stage, basically. And to some people, it means different things that are perhaps not approaching it from an academic standpoint. But something like clean code, not necessarily just clean code, it doesn't have to, like, it's not, this isn't about singling any people out, really. But just as an example of enshittification, and when it comes to code, we can talk about potential problems with clean code. I highly recommend anyone interested in problems with clean code to go and watch the Casey Motori video on it. But just to do a terrible summary that will not do any of it justice, clean code, we can ignore this term really, but basically clean code is sort of like, lots of people have been taught the way of clean code, either at university or just told online or by other people that it's the right thing to do, is to make your code as clean, quote unquote, as possible. And a lot of the times, if you were to really break it down in layman's terms, because I'm no expert myself, right? You're essentially talking about ways of organizing and structuring code. And it could mean any number of things, but you know, a lot of the time you're talking about object-oriented programming. I don't want to get into too specific topics with this, but the point is that it's sort of like fundamentally taught that it's better to design your code in such a way that's easier to read for X, Y, and Z reasons. But almost every single way of accomplishing that is actually adding a layer of abstraction. And the more abstraction you get in a large enough scale, gets back to this down here as some kind of scale of lost knowledge, right? Whether you are burying, you know, some sort of code in a method that's in an object that's whatever, or if it's a project that has like thousands of different script files that could be, you know, in one, and so you're burying literally where the code is located, which makes it harder and harder over a long enough period of time, over a large enough code base for the people working on it to really fully understand, which increases the likelihood that people don't fully understand it. That's like the fundamental problem of abstraction. But okay, abstraction is necessary evil. They have to work with in some cases. But what Casey Motori explains in the video is that sometimes, more often than you would think, many types of abstraction actually also can lead to less performance. And the reason why that's not really talked about is really just a summary of all of this. Like if you have lost knowledge, right? With lost knowledge, you can lead you down this sort of clean code path that's gonna lead to more lost knowledge and less performance. And he demonstrates it with actual practical examples showing how following certain clean code practices unnecessarily can create worse and worse code objectively, because not only is it abstracted, which is something that we're all used to having to deal with some layer of abstraction and having to go and look up where some code is, because it is more, you can be more organized that way, right? But it's also not only that though, we're taught that as essentially that's that trade is worth it because you're not told about this. And so this is a summary, probably a terrible summary of this idea of like things getting less and less performant. There's also another aspect, by the way, if you don't believe me. There's lots of tests online showing lots of different programs and applications essentially are on average sort of like starting to run worse than the software used to run. And so there's a reason why there's programmers out there still working with versions of Visual Studio from years ago, because it runs lightning fast. And part of that obviously is that if something had to work on less powerful machines, it will be fast now. But also the opposite is true, right? Where if you have more powerful machines, why does it feel shit if it does the same job, right? And the answer is all of this, right? Software is often not performant now. And anyway, that is me doing a terrible shorthand casual explanation at 12:30 midnight as someone without a computer science degree of what enshittification is. And that is the fourth reason why I'm trying to, I have made my own engine, technically. It's an engine. Just don't do much yet. But that's why. I think that it will make for a more performant game, which might actually make a better game. I get to improve as a developer. I actually think several things in my workflow, but it's going to improve my workflow, which I think might also make several things faster. And I don't want to contribute to the enshittification. That's the main point of this. This is a really, really hard topic to cover, and I need to make a video about it where it's well researched and well explained. But the reason I put this, why I wanted to explain this, sorry, I'll catch up on the chat in just a moment. See some interesting stuff there. But basically, starting thinking about this concept. What if you start to believe in shitification? If you start to believe in the conspiracy theory of the shitification of everything, and start to actually see and realize it and see it all around you of ways things are getting worse in tech and in software, and understands, as someone that's been making games for a decade, and kind of like the way I've learned everything is just like Googling things and watching YouTube videos and reading documentation and then just sitting figuring things out, and just doing trial and error. Is it a conspiracy if it's not a secret? Yeah, I don't know. I'm probably not doing a good job of describing any of this, but you know, I feel like as being a self-taught game developer that managed to do it professionally, I do feel like qualifies me to say certain things on this, which, in my opinion, like a lot of the paths that I have found myself on as a game dev has just been based on sort of like what everybody says you should do. What is the general consensus? What is trickling down from the people that are getting an education in it, right? What is common practice? And I have learned now enough to realize that lots of what is common practice is shit. And has led me astray, in fact. And so thinking about all of these things, the ways that I feel I've been pigeonholed into being a sort of worse developer than I could be, because I'm trapped in working in the same fucking engine for a decade. And all of the ways that I see everything getting worse and worse and shitter and more and less performant, and all of the ways it's cringe. Everything is just built on top of code base on top of code base that nobody fucking understands. I'm thinking like this is a problem that could seriously get out of hand and could see society as we know it crumble. I mean, it's an extreme take, but and me thinking, how can I fix that? And the only thing I can think of is like, people just have to choose to not be that way. And so I just decided to try and do that for myself and try and not be this way. You know? And so, yeah, everyone can hypothetically do their part just by, if you're doing a project, like it might not be the right thing for you, but if you feel the same way I do, maybe if you have the same outlook or a similar one, or you come to similar conclusions, maybe there's a way that you can not do this, not contribute to it. And yeah, maybe not. But if I'm making a game and I'm so early in development that I can go back to the drawing board and I can figure out how to do it all in C, then yeah, maybe I can do it. And so it's not just this. This is not my ethos driving me forwards. It's all this. But it's part of it. So thank you for coming to my TED Talk. Let's get rid of this monstrosity. I'll catch up on the chat now. How far back shall I go into it? Totally agree with the shitification of everything. We're trying to reverse it here in the USA. How so? Are you talking about the black box situation? Kind of, yeah. Sounds like Blighttown type of programming. It's not that I don't believe you, it's just that it's hard to visualize what you're saying. Too much abstraction is not good enough. Is not enough concrete. If nobody can maintain the foundation and everybody keeps building on top of it, not crazy to think that it could all fall apart. Exactly. Did we get there in the end, Santi, or is there something else that you feel like I'll be more clear on that we can talk through? I mean, like I was saying, how I started all of this, you know, I did do a comparison here before starting this between a proof of concept I did in C and what was a part of what we'd made in Game Maker. And this it fundamentally can't be a fair test for lots of the reasons we just described. But it is one of the simplest reasons to explain part of why I'm doing what I'm doing, which is just this: being in an IDE here for Game Maker, pressing compile, waiting for it to compile. Okay, now we're in here. Now disregard the fact that we have to wait here because this is sort of a transition screen for testing, so this isn't a load screen. But if I press spacebar, this is now loading. This, okay. Boom, right? And then this is like pulling in the data from our Rust program that we're, you know, in Game Maker we're turning into, you know, our world map essentially, right? And as a proof of concept, I decided to basically create the same fundamental system in C. And I mean, you know, it's not a fair test, but the difference is drastic. You know what I mean? Drastic enough to still get the point across. It's so much faster and simpler and nicer to go from writing code to just running this command to actually run it, right? And then how quickly I actually did the thing. Not a fair test, but illustrates part of what we're talking about, isn't it? However, this on the right is just a proof of concept that I did. It's not the actual project. I used AI quite a bit to help me get a proof of concept together. And this is, hand rolled so far. I was just commenting as you went, so it's kind of disjointed reading it all back at the end of your TED Talk. That's all good. So where do we go from here? Do we actually get something done? It's getting kind of late. Maybe just do a couple of TED Talks and wrap it up for the time being. Yep. I'm just thinking. Anything cool you can do with them as a result? hypothetically there will be. You know, you could just like loop through them mathematically, I guess. But yeah, I've just done it. The reason I've done it with integers is just because, you know, a string is not really being a thing in C. You know, you have to create an array of characters. So it just seems simpler just to do it like that. And then you know, they're defined as macros of up, down, left, and right. So it can still have the readability of it saying up, down, left, and right. So the type doesn't really make a difference, you know, from a readability standpoint. And, you know, hypothetically uses probably the smallest amount of memory it could do. Yeah, you could maybe do something like that, Zandy. It could be useful for stuff like that. I mainly just did it for the reason I just said. But there definitely is some potential to do some cool stuff with them being integers. I think oh, this is all kind of garbage right now. It needs to be totally refactored, but I think what we could actually do is talk a little bit about what an engine is and what it is we're actually doing and what we're up to. So you guys already saw the proof of concept, right? This just proves the basic thing of loading in the level data that we're generating in our Rust program that runs on launch and just placing it fundamentally shows us using the same tile set and placing them based on the level data and having a large world that we can pan around. This is sort of our world map, right? Hypothetically. It reminds me of Sea of Thieves where they use the same control scheme for the NPCs as a player, so they don't have to do some complex stuff. Yeah. So anyway, right now we're at a much more basic stage because I've now gone to hand rolling it instead of relying on AI as much whilst I was figuring things out. Where I just have this right now. Just a black square with a sprite. And I'm building each individual thing step by step that the engine needs to do. Now, when you think about it, not that much more needs to be added, right? We've got sprite handling. We've got movement. Do resolution independence next. I'm not sure what that means. But anyway, one of the key things with the whole development pipeline that I had set up with how I was working with Game Maker was I was working with the Game Boy Color palette and then using a shader to define the colors of each sprite. So that's why this face is red, because I was just figuring out doing that in C. Because this is actually this is actually just this, basically. Should be in render, actually. Wait, what was it called, that function again? Oh, it's camel case was bullshit. I think if we just do this, it should just be anyway. You get the gist. I think that yeah, what we can basically just talk about for now, and we'll maybe just leave it there because it is getting late. I've been yapping for a while already. So we're going to do a short stream tonight, but we can talk some more and answer some questions that people want. I don't really have. I need to. I don't think I have anything like short and sweet to code. I need to really get stuck in on some major things, which is probably getting a bit late for anyway. But I'm really happy to see people in the chat have been interested in this. We will do some more streams soon on this. But anyway, let me just read the chat and then we'll go through what sort of the basics of an engine basically is. And what we're doing in summary so far, and then we'll probably call it there. The engine controls rendering other types of output. Physics, input handling. Simple game AI. What's all this stuff? Not educated enough to know. What's me getting ready? Go and get me some grub. Oh, nice. Get some sleep so you can feel better. Yeah, that's probably good advice. So, this is just the main loop of the program at the minute, right? So this is like what actually happens. So all we do is we create a window. We run a setup function to just sort of set up and initialize a couple of things. And then we start the basic while loop of the program. And we start by processing input. So, you know, figuring out if the player's pressing any buttons, right? Then we update anything in the program that needs to be updated. So if there's something that's going on relative to input, for example, if we're moving to the right, we update the data here, right? And then we do actually render it. And this is all done whilst the game is running, right? While the game is running. And so if anything happens during this loop that is going to stop the game from running, like quitting out the game, we leave this loop and we run the destroy window function. And then that's the end of the program. And so that kills it basically. And that's really the fundamental loop that any game engine needs to be. We have this sort of idea of engines that are like very high levels of complexity. But an engine could be something very, very simple as well. And, you know, fundamentally, all a game needs to be able to do is take an input, update any data relative to that input, and render it. What does SDL handle for you? Seems like quite a bit. Well, we can go into some of this. So this is process import, right? So what? You don't. So SDL, right? What's going on with SDL is anything that if we like, obviously we're just working in C, right? And SDL is also just C, right? If we were to do things like handle player input, or you know what's actually maybe the best example with this is probably going to be this. Okay, I bounced off of OpenGL pretty hard using Allegro right now for a project. Nice. Yeah, what is SDL? So SDL is a library of C code. And, you know, everything we just said about enshittification and basically dependencies and abstraction, you could get to a point where, like, you don't rely on anything else, right? You wouldn't rely on any libraries, right? But here's the problem with that. There's a reason things are the way they are. It used to be, yeah, SDL does handle quite a few things, and we'll go through everything that it's handling in the project right now for sure, mate. Definitely get into that. But I'll explain why I'm using SDL first of all. It's the only library I'm using, and for now, it's the only library I plan on using, although that may change over time. But obviously, you could argue, I can't remember what SDL stands for, but it's not that. Everything I just said about the enshittification and people relying on code they don't understand and abstraction, you could see how someone like, oh, you're using a library. Simple direct media layer. There we go. That's it. But that is not the case. And here's why. So back in the day, basically before operating systems, you used to buy a computer and they used to come with a big manual. And that manual would essentially not just tell you how to use the computer, but tell you how to create programs for the computer, because there's basically no operating system, right? You type instructions on the command line, and that tells the computer what to do, and it does it. That would be the purest thing to do, really. Right. Now, the problem is, now operating systems are a thing. That's not possible. There is now an operating system between you and the CPU. So, if you want to address something directly, like, for example, we're going to talk about right here, get into specifics of what we were asking about right now. If you want to create a window, hypothetically, right, before operating systems were in the way, you type in the commands for the machine code, creates a window directly, right? No OS. Probably wouldn't really be handling Windows back then, but just type this, just humor me, right? Now there's an operating system. You can't do that. It is essentially security, you know, vulnerabilities to allow that to happen, and a million other myriad of reasons, right, why an operating system doesn't allow you to do that, but it gets fundamentally more complicated. Thank you so much for the follow on Twitch, by the way. I appreciate that. Boss Gans, thank you. So, if you want to create a window, the way to do that on every operating system is now different, because the developer of every operating system has chosen to approach that a different way. And you can no longer do it without the operating system. You have to work, if the software's gonna run on the operating system, you're trapped inside of it. No escape. You're in there already, right? If your game has to run on there, it's on the operating system. You can't circumvent it. Yeah, just to very quickly summarize, SDL can handle input, graphics, events, timing, sound, all the basics. If you are interested, if you're making a 2D game, it's all you really need. If you're making a 3D game, probably gonna want a little more. But SDL is still good as a base layer either way. I mean, Valve made Half-Life 2 with it. So, yeah. So anyway, back to what we was talking about. SDL is amazing. If you're going to start with one library to try and make games in C or C++, SDL is where I recommend everybody start. It's where I have started, but it's where lots of people recommend to start. And it's like industry proven too, widely used everywhere. There's a reason why it's in every. It's a dependency for every engine virtually in game made for years. It's in there. I'm exaggerating, but it's pretty much that widely used. So anyway, back to explaining, because this is why it's important for me. Because we're talking about avoiding any kind of dependencies and other people's shit, right? So if I want to create a window, now we're trapped inside Windows or Mac or Linux or whatever, it doesn't matter which operating system. If we're writing pure C code as God intended, the purest of code, it's not, but you know, I'm joking. You would have to write a series of, code, a series of functions and commands into your code. They essentially work with the Windows API to allow you to create a window. That code may be a little more involved than what you're seeing right here. Create a window, and it will be, but it won't be that crazy. But it will be a lot more work than this, right? We're seeing here, and that's hypothetically fine, because it wouldn't be that crazy to not use SDL if we're just talking about one platform. The problem is, then if you want to work on a different platform, or you want the games to run on a different platform, you need to write a set of code that directly tells the operating system that then tells the CPU to create a window on that. And so any time you want to work on a different operating system, it has to do that. Now, for me personally, I like to code on a Mac. It's the laptop I have. It's my portable computer. So I'm working on a Mac. My game, I am focusing on Windows as the end result for the game. Although how it's working now, it could be on any OS on a PC. And potentially even other platforms, but I don't give a shit about other platforms. But I just prefer to work on a Mac. And so, and if I wasn't working on a Mac, I'd be wanting to work on Linux. And so, it would just be a gigantic pain in the arse. To be able, I can't write the same code for Mac, for Linux, for Windows. I'd have to write the same function over and over and over again for each platform because of how the operating systems are in the way. And so what SDL actually does is, when you run this code here, like SDL init everything, and then, SDL create window here, and you see this is the window size 192 by 108. it's 1080p divided by 10. If you do the math there, chat, it's just because it's pixel art, right? What this does is when your program runs this, it knows, you know, what operating system it is running on, and it will, that code for the operating system, it will run. So it means you can run the same code on every single operating system, and SDL will just run whatever the native version of it is for each OS. So if I didn't use SDL, it would still be possible. It wouldn't be that much. It's not like from a technical perspective, it's that much of a bigger deal. It's just starts to become quite impractical. And when you start to go down this rabbit hole of, you know, trying to be more performant, trying to be more efficient, trying to increase your workflow, and that's why we're doing this. You could say you could be a purist and not use any libraries, but the reality is there is a level that's worth stopping at, because you're actually just start to become slower, less practical, more of a pain in the arse. And so that's why we're doing it. And so in this program specifically, we'll move on and I'll explain what all of these SDL things are doing, and we'll go through the main functions of the program that we just saw in the main loop, and then we'll wrap up. I was disappointed to learn that there aren't many crazy tricks in making a 3D engine. The native solution is the correct one. Yeah. Still translate to OS, yep. Universal translation. So SDL, you can do the work 1x, not 5x. Yeah, and it's like a good way of not having to worry about it. I can just make my game now without having to think about whether or not it will work on a different OS, because it works on everything. So anyway, our init window function. This just inits SDL, self-explanatory. And then we create the window. Any tips on convincing Microsoft that your game isn't a virus? I don't know. What's the context? What's the situation? What's the specific situation? I don't know if I'm going to be much help with that. I'm not working on Windows. And I never had it. Don't think I ever had that situation. It sounds like familiar, maybe on a game years ago that I had that situation, but I can't recall. So anyway, this is the create window function, and you just feed in all these arguments. This is basically the position. So they basically X and Y position, but if you just do SDL window position centered for both, it, you know, will center it. And then horizontal, vertical resolution, and then this is basically determining what type of window you want. Do you want it full screen? Do you want it minimized, etc.? This is just some error messages that we're doing here. Nothing special. And this creates a renderer within our window. Microsoft doesn't like small C programs developed by nobody. I mean, I was writing lots of Rust programs. I run into no problem on my computer for my project. So, don't know why C would be any different. But I haven't run any of the C programs on Windows yet. I'll have to get back to you about that. But I don't see why it would be different to Rust. More error handling for the renderer. And this is initializing the size of the renderer. So we're just creating a renderer at the same size as the window. It's not an issue for me, but when you try to distribute, it becomes an issue. I mean, I don't know, dude. I've made games for like a decade and never had this problem. Many of them went to market. Did the bot time somebody out because they didn't put a space in between the dot? Bots are so dumb, honestly. Where's my drinks? I moved my drinks to right in front of me, which is hilarious because they never normally are. Is it possible there's some flag that you're not giving the compiler? So now we're in our input script anyway. Here we create an SDL event, just called event, and we start to poll the events with SDL poll event. So it's going to keep a record of the events currently happening. So then we check the event type, and we look for an SDL quit event, which is something that SDL does. It's an SDL event. And if the event type is SDL quit, then we set game is running to false, which if you remember breaks the loop and therefore closes the game and runs destroy window. We also check key down and we check for the key press event for escape, and that does the same thing. So that's just handling closing the window. Something I figured out using SDL is using event pollen isn't actually always the best for handling player input. It's not as responsive. It essentially responds as it like typing on a keyboard. You got your from spamming all caps. That's weird. I don't remember setting that moderation setting. I wonder if it's different on YouTube. Yeah, so the way to think about event polling to handle your input is that it sort of like responds after you've pressed the key, like typing letters on a keyboard in a text editor. Whereas getting the keyboard state constantly allows you to do more like joysticks type input handling. So I'm doing a different method of input handling for movement because it just feels a lot better. It's something that I found in my proof of concept. And after looking it up, it is totally a thing that people mix and match event polling with keyboard state depending on what type of input they want, you know, how they want it to feel when you press a button. And so what we're doing here is creating a constant that stores the keyboard state. And so by doing that, we can check the keyboard state for the same sorts of things. You're just looking for scan codes in the keyboard state for each button, as opposed to events being pulled. So we're doing that for up, down, left, or right. And depending on each of those, this is obviously not SDL here, just this is here and here. We're just setting our move direction based on that. And then we're just saying if none of those are our current keyboard state, we're setting the move direction to stop. This isn't really part of the game loop yet. I'm still working on this, but it's to do with recoloring. SDL also can handle this, which is kind of awesome. This is all kind of like shit I've gone backwards and forwards with, so I need to refactor this. But just to show something cool is basically you can get the entire working surface basically from the renderer, and literally so this basically you feed your sprite into it because it's being converted to a surface, and it will actually create an array of every pixel within the surface and what color it is. Which is pretty awesome. And so this is the color we're changing it to. And this is just saying, like, if the colors are within this range, you can literally just type in the color you want to change each pixel to manually here if you wanted to, but obviously we're just looking at a specific one. Like I said in YouTube chat, just yell it's not a virus, Bill, at the PC, and it should do it. And then then we just turn it into a texture and feed it back into a renderer and feed it up for the surface again. All I could think of I mean, what does Google say, Weeaboo? I assume you've Googled it a lot. Because the only thing I can think of at the top of my head is some sort of flag that's not being given to the compiler. But that's just a wild guess. So this is our input function. This is our setup function. And what we're doing in setup is actually loading our sprite. So obviously it's a file in our assets folder that needs to be loaded. So we're creating a surface in SDL. We're loading the image from the asset directory. This is just some error handling. This is just running that set color thing from before. That's freeing the surface. So that's all we're really done here, is just set up a surface that contains the sprite in our setup. We've not got much going on. And this is our update function. So this is actually really important. A lot of this is self-explanatory, but this is well important. This tiny bit of code here. So one of the big problems, a hurdle to get around with making game engines, it's really simple to get around, but it's funny because it's a common problem that we'll probably all be aware of in video games, which is the idea of the tick rate being locked to the frame rate. So obviously the tick rate is the rate at which, you know, everything operates that you want to run every step in the game, right? So if you're holding down right and you want to move 1 pixel at a time, you move 1 pixel every tick, and if that's directly linked to your frame rate, if it's running at 60 FPS, you will move 60 pixels a second, right? Tick rate, frame rate can really mess up physics in running old games on new hardware. Yeah, it's funny, like even like Dark Souls back in the day had a problem when it sort of came to PC, where they had that issue and weapons were breaking faster on better hardware. But it's actually an easy problem to solve, because what you need to do is create delta time, which is essentially just a fancy way of saying relative time, right? And so that's all we've done here, is create delta time. So creating a float variable called delta time, right? Then we have this called SDL get ticks. And what this does is basically this keeps a running tally of every single tick that has run since the program began. And all we do is minus the last frame time. So we minus the point that the last frame happens. So that gives us the difference between the current frame and the last frame. And we divide that by 1,000. So it means that we know the difference in time. So we know how long it's taken. Right? And we set what the last frame time was here. So you see this is sort of storing it, because this is a loop, so it loops over and over again. If you're following me. You see, yeah, you follow me? Okay, cool. So then, for our actual real move speed, I have a move speed global here, which is just the actual global value of what I want movement to be. And so we're setting our actual, like how we're actually going to move, which is this move speed value here. And we're timesing the move speed by the delta time. And that gives us a relative move speed to the delta time, which is going to be the same regardless on the hardware or the frame rate, because it's based on the counting the ticks and when each frame happens, basically. I hope that makes sense. And then all we're doing is setting up a little struct here. We're doing type def struct because it's more type safe. It can only be this type. Don't need to worry about that really. Just so we can do sprite pos.x and sprite pos.y instead of him two separate variables. That's more of a choice in taste there. And we're just saying, you know, if the move direction is not stop, you know, plus or minus by the move speed. And we're setting variables for that as our next position. So we're saying we want our next position to be plus or minus by it. And then we're updating here at the bottom by setting our current position to our next position. Because obviously all of this is constantly looping over itself. Yeah, the map keeps it constant. Then we've got a tiny little renderer, cute little renderer. Set render draw color. So how things work in SDL, lots of engines, lots of different frameworks and libraries and stuff will do things, and engines will do things this way, lots of renderers. It doesn't have to, but this is what it does. To explain. If you think about how rendering works in a video game, just think of like playing GTA or something and you see an object render in the distance. Yeah? It pops in. We don't really like pop in, do we? Right? So what this renderer does is it basically renders a blank screen, and behind that blank screen the objects will render, and once they are actually rendered it reveals them. Does that make sense? And what that does is it stops this effect of things just popping in, hypothetically, right? So what this draw render color does, this sets the color of the quote unquote background of what's happening when things aren't being rendered. So this basically will set the color of the window in our current thing, because our screen's not full of sprites at the minute. If it wasn't, you'd never see it unless something wasn't actually rendered, right? So this essentially sets the background, but that's also what things are going to be hidden behind before they're not rendered. This is just saying what part of the sprite to render, essentially. So this is like from the top left pixel to the bottom right pixel, because it's 16 by 16 sprite. So that's our source rectangle. SDL rect is a way of drawing rectangles. And then our destination sprite rectangle, that's what this is just drawn at our relative position that we're setting, and this is just the size it's being drawn at. So this here is essentially it being rendered, and then this is what we actually see on the screen. So this thing that's hidden that we talked about being rendered, this is basically this, and then this is the bit you actually see, and then you can see here SDL render copy. So this is the name of the renderer. We set the name of the renderer up here, right? Our texture is what we set up in the setup function, and then we are copying from the source sprite rectangle, which is hidden, to the destination rectangle. Yeah, this is yeah. I mean, this isn't my idea. I learned it just by watching videos and reading and stuff. But I wrote all this. And then render present is just showing you the renderer. So this is sort of the thing that shows you it once it's rendered. This is the, the thing that I said that it renders first and then you show it after it's rendered. Well, that's what present does. So it's just telling you which renderer to present. So that's why this has to happen after all of this, because otherwise it would do what we're saying, right? And then the little function to destroy the window, which happens when the loop is if you remember the while loop from the main function. In fact, it's right here because we're done. Remember, if anything ever tells that the game is running variable, that it's false, we get to leave the while loop. It then destroys the window to end the program. So it'll destroy the window basically if there's no... Oh, sorry, no. If there is a sprite texture on the screen, it destroys it. Then it destroys the renderer. Then it destroys the window. Then it quits the image library, which is the part of the SDL library that handles images. It's actually a different... If I... yeah, so here you can see in this right pane, this is just the build command for compiling the program, right? So these are the instructions that we're feeding in, flags that we feed into the compiler to tell it what to do when we compile. And so SDL2 is everything that says SDL, that's the SDL library. SDL also has an image library to do with image handling. And so we're saying to compile it with SDL and SDL image. And therefore, both those things need to be quit when you destroy the program so that you're not leaving anything behind, basically. And then that's it. The main function we already went through, but now you understand what it does. I must have added this test printout for a specific reason. I think that was... This isn't supposed to be here. I must have added this because I was testing something. But yeah, game is running equals the init window. That's just because, something we didn't talk about is just how this init window function here returns true. At the top here, we've got some macros. Well, we can type true, but it mean 1, and type false, but it means 0. And we can type up, but it mean 1, and type down, but it mean 3. So anywhere that says 1 is interchangeable with typing true, and etc. Right? Just to make it more readable. So actually, yeah. Hypothetically, some of these things could be renamed if you wanted them to. And it would still work. But because that will return 1 once the window is initialized, that will set it to 1. Yeah, bool is the simplest one, yeah. And then, yeah, the setup, which just sets up our texture for our sprite. And then we process the import. We update, we render, destroy window. That's everything. Way simpler than Unreal. It is. This is like all the lower level stuff I've avoided in Unreal. Way simpler than Unreal. Yeah, so there's a really good point in that I obviously have come at game development from the angle of working with engines. You know, I've got 10 years of experience working in Game Maker almost exclusively, but during that time I have also oh, okay, it's just a binary. A different binary. Yeah, and now it's the same binary. So yeah, so we shouldn't have changed anything. Yeah, so I've obviously come with that direction too, right? I actually, what's so weird is that I've ended up writing C code with SDL just because from doing research, when trying to do what I wanted to do, this is what my research told me was the best option. And I found good documentation and guides. And when you start looking on forums and stuff as well, it seems to be the general consensus that this is the best place to start for doing something like this, right? Do you know what's so funny? Like 10 years ago, when I had no idea how to make games, and I started learning, I literally, weirdly, ended up in the same spot. I ended up sat there trying to write C. I think it may have been C++, but also SDL. I ended up sat there trying to figure out how to use SDL. And either C or C++. I actually don't remember because I wouldn't have even known what the fuck I was talking about to tell you the difference back then. And it just seemed way too complicated because I didn't really know shit about programming. I've only done the very basic stuff in Python. I didn't know anything. And what I learned was that there's a bunch of people making games with engines. Game Maker is the one I ended up settling on, but I tried Unreal, I tried CryEngine, I tried Unity. And everything just felt overly complicated to do what I was trying to do, which is a 2D pixel art game, which is why I ended up with Game Maker at the time. Still kind of the best if you want to go with an engine to make, 2D pixel art stuff, really. But anyway, I ended up there because everybody says it's simpler, and because, when you watch, there's plenty of tutorials and guides out there online, and when you follow them, it seems easier to understand. But after actually doing this now, this was actually way simpler in a lot of ways. To go basis for a program. It is. Again, I didn't get the ideas for the basis to function in exactly this way, but it is kind of beautiful in its elegance and simplicity. Use the universal library like SDL in C and make all the code you need from that. Yeah. I'm going to try and just stick with C because part of the reason why I'm here is the language itself. So I'm going to avoid C++ because it's not just about abstraction for me. Part of trying to find the best way that works for me, so everything, a lot of what we talked about today are kind of objective things that apply to everything. One of the aspects we've not talked about much is some of the subjective things. Now, one of those things is workflow. This workflow of just being in the terminal and writing code and running, just working like this may not be for everybody. But the other aspect is just the actual language choice. Because one of the things I realized So let me actually maybe let's so Rust is one of the other programming languages that people absolutely rave about online and as being the best. There's lots of Rust evangelists out there that feel like it's like the best programming language for lots of reasons. It's a low-level language like C or C++, but it, you know, it's essentially guaranteed to be memory safe in a way that C and C++ and stuff is not. Python, you wouldn't, or SQL, you wouldn't really use in these sorts of contexts. But Rust is a fast, low-level language that supposedly has all of the you know, advantages of C in terms of oh, you listen off languages, you know. Got you. So the benefit of Rust is supposed to be that it has all of the speed of working with something like C, with all of the memory safety of something that comes from a high-level garbage collected language, just like something crap like JavaScript or something. I say something crap. There's good ways to use JavaScript, but if you're trying to do something low level, it's not going to happen with JavaScript. Right? So, one of the things about why people scare you away from C and C++ is the idea that because you're directly allocating things to memory, you need to really understand how the computer works, and it's easy to make mistakes that cause memory leaks, right? One of the ways many of these programming languages solve this problem of mistakes causing horrific problems with the computer is by, you know, garbage collection. And garbage collection, in a nutshell, slows down the program, slows down the compilation process. But what it does is it catches your mistakes and in some cases may even correct them. And so that's the real difference between some high-level languages, like a JavaScript or whatever, and something like a C is like garbage collection is a big part of it. But garbage collection is slow and it slows things down. So that's why working with low-level things is still worth it to be more performant, but it comes at this trade-off that you have to be careful what you're doing with memory. Rust's great innovation was essentially using some of its own technology with the borrow checker to essentially not do garbage collection to still remain fast, but to make sure that those memory leaks don't happen. So it's supposed to be the best of both worlds. So I made this Rust program, and this Rust program generates all of the level data. In fact, we can run this Rust program here, and it will generate this text file. And this text file is all of the data of one of those levels that I was just showing you with the proof of concept that I had going in GameMaker. So it's 1 million characters, 1,000 lines of 1,000 character lines. To contain the whole world map as a text file. And that gets read by GameMaker. And I did this because I wanted to learn Rust, and I also thought I might be able to accomplish some things that GameMaker can't do, and I was right about that. Now, my experience writing Rust, I like it. It was good. But some of this stuff, yeah, it's horrible to look at the text output. Some of this to me, I just feel like there's some of the syntax and stuff. It looks a little verbose, like a little bit longer than it needs to be, and it's not overly clear what everything it does just by looking at it. It's not so self-explanatory to me looking at Rust. And now I've been working with Rust for, longer than I've worked with C. I'm brand new to C. And I already feel like I understand what's going on just by looking at C far clearer. And so one of the reasons why I could be working in C++, because, all C code works in C++, so we can do the same thing with C++, and, it's more widely used now. But I don't care about getting a job. I just found from looking at other people's code that C just seemed more elegant, more nice to look at, and just easier to understand, easier to read to me personally than any other language that I've worked with so far. And so there's also an aspect to, the sort of subjective nature of this. I'm currently finding C code easier to read than anything else. And so I'm just sticking with just pure C rather than going with C++, because that's an important element too. And that's going to be subjective. Some people might prefer, reading and writing different languages. And it's something worth bearing in mind. I mean, you can hypothetically be like, oh, this language is the best for the job. True. But in the real world, there's going to be certain languages people like to write and certain languages people don't like to write. And I am finding C as a language of absolute pleasure. And the reason I'm finding it a pleasure is it's insanely simple. Might be the best for the job, but it's the best for you. I think it's both, personally. But if you wanted to get a job in the industry, if I was seeing this as a portfolio piece to get a job, as opposed to it just being a personal project, right? I personally just fucking hate the idea of doing it as a job. This is my job. I'm doing it for myself. I'm a content creator. I have the advantage that if I make this game, I can potentially sell it to my audience. So this is my job. If I wanted to be on the job market to go and work for somebody else, it might be smarter to work in C++. That's what you were saying, right? I mean, the question about which language to use. Oh, yeah. I mean, yeah, yeah, for sure. Yeah, there's definitely... I think when choosing a language for a project, it's really good to consider what a language is good at and the pluses and minuses of it as to figuring out whether there is like an objective best language, quote unquote, for the job. But the reality is you're almost never going to find that brings you to just one language. And if it brings you to several, you're probably going to want to choose the one that that you want to work with the most for whatever reason that is, whether it's readability or whatever. It might get the job done better, but if you hate using it, you're going to give up due to frustration and pain. Kind of defeats the purpose of getting the thing made. Yeah. Exactly. Right, I think we're going to call it there because we've summarized everything pretty good now. And it's getting late, so thank you for watching. I really appreciate it. Thank you, Zanti, for being interested and watching the Valheim stream on this one. Really appreciate that. Shout out to anyone else that's done the same. I'm going to go to sleep now and hope that I feel better soon. But thanks a lot for watching. And yeah, I'll see you guys soon for some more Valheim and some more game development. Night.